Alright, today should be a review, like the last set of notes. We're talking about polygons. Not going to get real in depth. This is just a couple of the basic concepts of a polygon. First of all, you'll see or hear the word diagonal several times, so let's talk about that. It's a segment that joins two non-consecutive vertices. Each one of these places where it changes direction. Two lines intersect here. That's called a vertex. Multiple ones, more than one, is called a vertice. And so if they're not consecutive, like these two here are consecutive, back to back, if they're not consecutive, you can make what's called a diagonal. Now that's just round. I can't draw, but you get the point. A diagonal is here and here, as long as the vertex or vertices are not consecutive. Concave and convex. Any part of a diagonal that contains points on the exterior. So we got the inside of the shape here and the outside of the shape. We call it concave if any part of it is on the inside. Whoa, didn't want that to happen. So let's look. If I draw this picture right here, notice if I take a diagonal, like those two vertices are consecutive and this one is not. You see how it's outside of the figure and these are on the inside? This is called a concave figure and this one is called a convex. Basically the difference is all the diagonals are inside and convex. It's like whole all together, and in the concave there's parts that are outside where you can draw a diagonal and be outside of the figure. A regular polygon is one where it's equal angular and equilateral. That means all the angles are all the same. That means all the segments of the sides are all the same. And so if I say regular, that's very important. It's trying to tell you something really important. Here's a theorem that you need to know, and this is one you're going to use a lot. Polygon interior angles theorem. What this theorem basically says is n is the number of sides that you have. If you use this formula, n minus 2 times 180, it will tell you how much each one of your interior angles adds up to be. It won't tell you what each individual angle is unless it's a regular polygon and they're all going to be even. It will simply just tell you, if you add them all up, what it'll be. So here's another part. You should know that a quadrilateral, that means 4 sides, it's always going to be 360. A square, rectangle, something like that, it's always going to be 360 degrees. This right here is something that you probably need to remember. The prefixes penta and hexa, hepta, all these are kind of giving you a hint of what number represents. Anything over 12, let's call it like that number gon, like 15-gon. You know it has 15 sides, or 20-gon that has 20 sides. And so triangle, you know what a triangle is, and a quadrilateral. And so these are good to know. They'll ask you things depending on a nanogon, for example, and you need to know that that's 9 sides. Alright, here's an example. Find the sum of the measures of the interior angles of a convex hexagon. Hexagon has how many sides? It is 6. So what you would do is simply, you would say times 180 720 degrees. That's a times. Find the value of x in the diagram shown. Okay, so this is 1, 2, 3, 4 sides. We know that a 4-sided figure is called a quadrilateral. This should add up to be 360 degrees. So how do we work this one? We say x plus 135 plus 112, which was a club in Atlanta back in the day, plus 71 equals 360. And then so x equals 42. Just that simple. Here's a formula for exterior angles. Notice that at each one of these there's only one angle, so you could actually draw a line here and make two angles or more than one angle. We're not doing that here. If there's only one angle at each vertex on the outside, then I don't care how many sides it has, all the sides add up, or all the exterior angles add up to be 360. This is what you need to remember, that all the exterior angles add up to be 360 if it's only one angle. So if we could find the x, solve for x here, there's a little hint right there, then this is what you would do. So here's the work. Add them all up, set them equal to 360, and solve for x. Just that simple. Well, that's it. We'll probably have assignments based on this theorem and this theorem here. Remember, these are important to remember. Any questions? Ask your mama.